In this video, we'll look at how to use sine law to determine angles and sides. So question 1 is about determining an angle. Let's start with that. Then we'll do question 2, determining a side. I've labeled this triangle ABC. You would have been given all this in the question, and ABC has corresponding sides to the capital letters. Those are the lowercase letters. So for example, this is angle C. We call lowercase c, or baby c, the side across from angle C. Similarly, this is angle B and lowercase side B. This is angle A and across from it, baby a, or lowercase a. The question would have also given you some information. In this case, I've told you this angle is 76 degrees, this side's 59 in length, and this side's 41 in length. And I want to solve for this angle C, and I called it X, just so you could see what I'm solving for. When you're doing sine law, you want a pair of side angle and another pair of side angle. With sine law, you always need to have three things, and you're looking for the fourth. And I always put what I'm looking for in the top left. So let's set up sine law. I'm going to look for sine of capital C, and I match it up with its corresponding side, baby c. And I use the other pair that I know, which is going to be sine of B, capital B, over its corresponding opposite side, baby b. First step is always the equation. Second step, sub in. I'm looking for the sine of X. You could have called it capital C and left it. I just called it X because I like it. Divide by lowercase c, the side corresponding. That's 41 equals sine of B, that's the sine of angle B, or sine 76, over the baby b, that's 59. Alright. Now we got to get sine x by itself. Well, sine x is being divided by 41. What's the opposite of dividing? Timesing. So I'm going to times both sides by 41. And what I get is sine x equals, and I'm going to compute this whole side here. I want to figure out what that is. I'm going to get a big long decimal. I'm going to write all the digits. This is sine 76, calculators in degrees, yep. Sine 76 times 41. You don't have to hit equals every time, but some calculators are finicky. I just make sure. And I got a big long decimal that I need to write down. Sine x is 0.674273,301. Okay. Not there yet. And one thing worth noting is, even though I kept all the decimals, and you should, technically the calculator is still rounded here. This is still approximate. I need a rounding dot here. Next line. How do you get rid of this sine? Sine is a function. You can't divide sine. That's impossible. To get sine off of an x, you've got to inverse sine. If it were dividing, it would be times. It's not times in here. It's sine of x. So how do you undo sine? You inverse, or sine to the power of -1, in order to get that angle x. I got to rewrite this big long 0.674273,301 number. And notice there's no rounding dot here, because from this line to this line I rounded. This fraction became approximately this, but from here to here it hasn't changed. No rounding. No rounding dot there. But on my last line I'm going to round for sure, because I'm going to ask the calculator, hey calculator, what's the inverse sine of, and you need a bracket on some calculators. I know I don't here, I'm going to leave it out. But make sure you know your calculator. 647273301, inverse sine that. And I'll round to the nearest degree, it's 0.3. So round down, and I get approximately 42 degrees. Done. I use sine law to determine an angle. Now I'm going to use sine law again to determine a side. You'll notice this triangle, I didn't label the triangle ahead of time. You don't have to label the triangle. I just like it, and you can get part marks just by showing the formula. So let's do it. Let's call this angle A. Let's call this angle B. Let's call this angle C. You can call them anything you want, but that's what I chose. Okay, again I'm working with a pair, and I'm going to use the pair of, let's see, I got 50, and notice it matches the side across, the angle across from it, which is that, and Y matches the angle across from it. One problem, I don't have that angle yet, but I can get it because I have two other angles in a triangle. And hopefully you know an angle in a triangle, if you're given the other two, is just 180 take away those other two angles. Or all angles in a triangle must add to 180. So if you got two of them, just subtract them from 180. Whatever's left over, that's going to be the missing angle. What's 180 minus 41 minus 57? You get 82. Okay, now I know this is 82. And now I've got what I needed. Just like I said in the first example, with sine law, you need a pair of angle side, but you need to have 3 of the 4 pieces. So I got this piece now by doing the 180 minus, angles in a triangle add to 180 idea. So now I can use my sine law. And I'm going to solve for y. Let's label the sides just to help you see. This is angle A, so across from that, this would be baby A. This is angle B, so this is side B. And this is angle C, so this would be side C. Okay, always put what you're looking for in the top left of your two fractions. Last time I was looking for angle C, so I started with angle C at the top. Here I'm looking for little baby B, so I start in with my formula with baby B. I'm going to put a little line here. Put baby B on the top, and sine law is always the side, and then the matching angle, sine of that angle. So little b over sine B, and this is the side, that's the angle. And now the other pair I have is side C and sine of angle C. Always start with the formula. Step 2, sub in. I don't know B yet. Oh, but I called it Y. I'm going to put a Y there. Could you leave it as B? Sure. Nothing wrong with that. But I'm going to call it Y because I already had. That's Y sine B. So that's the sine of 82 degrees for angle B equals C. What's C? 50. Over sine C. That's the sine of 57. Okay, it's all set. But now, I'm going to extend that. Now I got to get Y by itself. Y is being divided by something. Whenever you're dividing and you want to clear away that fraction, you do the opposite of dividing. What's the opposite of dividing? Timesing. I'm going to times both sides by sine 82. And that gives me, well, times and then divide by the same thing. Those cancel and you just get Y. And on this side you get 50 sine of 82. You could put brackets here if you wanted. Let's do it just in case. But most of the time you don't need it. Like, you don't need it when you write it. Most calculators don't need it either, but I'm going to put times on my calculator. Oh, what do I have here? 50 times sine 82 over sine of 57. And finally I'm going to solve. I'm going to ask my calculator, what's 50 times sine 82? I can put equals. You don't always have to, but again, just to be safe, I did. Some calculators are finicky. Divide by sine 57. Round to the nearest degree. I get 59 degrees. Put a rounding dot. So in both of these questions I use sine law. In the first question I use sine law to determine an angle. On the second one I was determining a side and I said it was degrees. That's crazy talk. Better fix that. Let's do that right now. 50 times sine 82. Good thing I checked my work. Whew. Divided by sine 57. Whoop. And you get 59, but not degrees. This is a side. I'm going to round sides to 3 decimals. So I get 59.03. What's after the 3 is the 7. I want to write a 7, except after the 7 I'm rounding to 3 decimals. So I check the 4th decimal. It's a 9, which means round up. So 59.038. Good thing I checked my work. And when I was checking, I saw here we determined an angle. But in this question here, I use sine law to determine a side. And usually I round sides to 3 decimals. There you have it. How to use sine law.